Next, we're going to talk about the measures of variation. So the values that describe the spread or the distribution of your data set. How far apart are your numbers? How close together are they? And we have 3 values that describe those characteristics. We're going to talk about the range, the variance, and the standard deviation. First, we will look at range. To calculate the range, we will take our highest number minus the lowest number, or our max value minus our min value. So in the example below, I have a list of numbers and we're going to find the range for it. Our smallest number is 2 and our highest number is 199. So to find our range, we will take the biggest number, 199, minus our smallest of 2, and get a range of 197. The variance is the measure of the average spread of data around an expected value. And usually this expected value is the mean. We have 2 different symbols for variance depending on if the variance is of the sample or it is calculated from the entire population. For the sample, we use S squared. For the population variance, we use sigma squared. The standard deviation is another measure of variation. It is simply the square root of the variance. So once you have variance, all you do is take the square root and you have the standard deviation for that data set. So our 2 symbols for standard deviation are for our sample and population. For the sample, it's just S because you have taken the square root of your variance. And for population, it's a lowercase sigma. Another way to think about the standard deviation is our average squared distance from our center, or the density of our data, how spread apart our values are, or how close together they are. So if you have a small standard deviation and it's symmetric, then your distribution curve will be a little bit taller and not so wide because your data values are all close together. On the other hand, if you have a large standard deviation, then your curve is going to be a little bit more flattened and spread out because your values are further apart and your set is larger in its range. We have 2 formulas for calculating the population, standard deviation, and variance. The only difference in these formulas is that for the standard deviation, we are taking the square root of the variance because that is how these 2 values are related. So once we find the variance, if we simply take the square root of our answer, then we will have the standard deviation. We've seen a few of these symbols before, but let's make sure that we understand what each one means. Sigma means the sum of. So what is within our parentheses, we will be finding those values and then adding all of them together. X stands for each value within our set. So we're going to have to do a calculation for each value in our set and so X will be different each time. Mu, if you remember, is the symbol for our population mean. So it's the average of all of our numbers. So we are going to take each value, subtract the mean, square that, and then add all of those squareds together. On the bottom is N, which stands for our total number of values. How many values are in our data set? Example 10. The data below represents test scores for Ms. McNeil's entire second period class. Calculate the variance and standard deviation for this population. The easiest way to solve these formulas is to help organize our results and our calculations within a table. So I'm going to go ahead and set mine up. We're going to have 3 columns, one for our value, one for our value minus our mean, or x minus mu, and one for the square of x minus mu. Now, before we can start calculating, we have to find mu. So we have to find the average of this population. So we will add all of those numbers up. We get a sum of 1,020, and we're going to divide it by the total number of students whose test scores we have. So we have a total of 12 test scores. So when we divide that, we get a mu of 85. I have gone ahead and written down all of our x values, so now we're going to take each value and subtract our mean. So for our first row, we have 67 minus 85, and that gives us a negative 18. Now it's okay to have negative values in this second column, because if we take a smaller number and subtract a bigger number, we're going to get a negative number. That's okay. Okay, next row, 83 minus 85, so we get a negative 2. Now I want you to go ahead and pause the presentation and finish filling out this second column, then we'll check our answers and go to the third. Okay, so take a minute to check your differences and make sure you have the same values. Okay, next we're going to square each of our values in the second column. Since we are squaring our numbers, that means that any negatives we have, once we square them, should come out to be a positive number. So all of our values in the third column should be positive. So negative 18 squared gives us 324. Positive number. Negative 2 squared gives us 4. Now I'm going to let you pause the presentation and finish filling out this column. Now take a minute and check your squares and make sure that you have the same answer. Okay, so off to the right, I have rewritten our formula for variance. We already have the values from x minus mu squared. So we need to next add that entire column up to get our sum of those squares. When we add that column together, this column right here, you should get a sum of 708. And now we will divide that by n, or the total number of values or test scores that we have. And we already figured out that that was 12. So our variance is 59. It also asked us to find the standard deviation. So to find sigma, all we need to do is take the square root of 59. And since this is going to come out to be a decimal, we're going to write our standard deviation and variance anytime it comes out to be a decimal with 3 decimal places. So we get 7.681 for our standard deviation. To find the standard deviation and variance for a sample, the formula is just a little bit different because we have to account for the fact that when we're working with sample data, it might not accurately reflect the entire population. So therefore, if we use our sample mean, if we don't know the entire population's mean, we might have a little bit of a difference in our calculation if we use our formulas for population, standard deviation, and variance. So to make up for that slight difference, in our denominator, we have n minus 1. instead of just in. And the only other difference that you might see is that instead of mu, we have an X bar. And that's because we're working with sample data. So now the mean that we have is from our sample, and we denote that using an X bar. Just like before, to find our standard deviation, we're simply going to take the square root of our variance formula, or our variance that we've already calculated. Example 11. The data below represents the number of hours slept last night from a sample of students at Peeling High School. Calculate the variance and standard deviation. So we want to start by finding our sample mean, which is denoted as X bar. So we will add together all of our data points, get a sum of 49, and divide this by the total number of values, which is 7, because we talked to 7 students. That gives us a mean of 7. Just like before, I would suggest making a table to keep track of all your calculations, and it just makes it easier there for you, or less likely to make careless errors. I have gone ahead and filled in my values, but if you ever need to catch up with the video, just pause it, catch up, and play. So next we're going to take each x value and subtract our mean. So 6.5 minus 7 would be negative 0.5, 8 minus 7 would be 1, 5 minus 7 would be 2, and we're going to do this for the rest of our chart. Now for our third column, we are going to square each value that's in the second column. So since we're squaring, we should get all positive numbers in our third column. So negative 0.5 is 0.25. I'm going to let you go ahead and fill in the rest, and then you can check. So go ahead and pause your video, calculate, come back. Go ahead and check your answers. And as you notice off to the right, I have written in our formula for variance to get the sum of our squared values of x minus our sample mean. We're going to take the sum of this third column. When we add those squares together, we get 10.5. Let me draw a line so we don't get this confused. Okay. So our numerator in our formula is 10.5. Our n is our number of values. We had 7 people interviewed, so our denominator is going to be 7 minus 1, which means we're taking 10.5 and dividing it by 6. This gives us a variance of 1.75. And to find the standard deviation, we're going to take the square root of 1.75. We're going to round this to 3 decimal places. So we get a standard deviation of 1.323. This is the resources page. This is the textbook that was referenced during this presentation. You can use this as a resource, and be sure to check out the other supplemental materials on this lesson module.